Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0103, indicates a high voltage condition detected in the mass airflow MAF sensor circuit of the Honda Odyssey, specifically from model years 2011 to 2017. The MAF sensor plays a crucial role in measuring the amount of air entering the engine, which is vital for efficient fuel injection and ignition timing. Accurate data from this sensor helps the engine control module, ECM, make necessary adjustments for optimum performance. The location of the MAF sensor is typically found in the air intake system, usually positioned just after the air filter and before the throttle body. When the MAF sensor reports a voltage higher than expected, it may trigger this DTC, leading to potential engine performance issues or increased emissions. Before diving into troubleshooting, it is essential to record any freeze-frame data and onboard snapshot data to provide context to the current condition of the vehicle. DTC P0103 signifies a high voltage occurrence in the MAF sensor circuit. The MAF sensor, responsible for calculating the volume of air entering the engine, impacts engine performance by assisting the ECU in optimizing fuel delivery. The sensor's function is integral to maintaining the air-fuel ratio, essential for efficient combustion. The typical location of the MAF sensor is in the air intake system, situated just downstream of the air filter, yet upstream of the throttle body. As the engine draws air, the MAF sensor detects the airflow and converts this information into a voltage signal set to the engine's PCM. An unexpected high voltage can indicate either a malfunction within the sensor itself or issues elsewhere in the circuitry, leading to performance problems or emission failures. Several potential causes can lead to the P0103 code being triggered. A faulty MAF sensor is often the primary suspect. Over time, these sensors can degrade or become damaged, resulting in incorrect voltage readings. Additionally, poor electrical connections can cause intermittent signals, ultimately leading to errant high voltage conditions. Loose terminals, corroded connections, or frayed wiring between the MAF sensor, intake air temperature, IAT sensor, and the powertrain control module, PCM, can also negatively impact the circuit, making it crucial to inspect these areas thoroughly. Furthermore, damaged or chafed wires in the harness can lead to short circuits, thereby affecting the MAF sensor's performance and causing the DTC to trigger. When experiencing DTC P0103, you may encounter various symptoms that indicate underlying issues with the MAF sensor. One of the most noticeable signs is the illumination of the check engine light, CEL, which alerts the driver of a performance issue. Poor acceleration may also be observed, as the engine struggles to adequately mix air and fuel due to erroneous data from the MAF sensor. Increased fuel consumption might result as the ECU attempts to compensate for incorrect airflow readings, leading to overly rich fuel mixtures. Additionally, rough idling can occur due to the improper air-fuel ratio, further affecting engine performance. It's essential to address these symptoms promptly to avoid long-term damage to engine components and to sustain optimal vehicle performance. The first step in troubleshooting the P0103 DTC involves turning the vehicle's ignition switch to the on position, specifically to position I, and allowing it to remain there for a minimum of 2 seconds. This action primes the electrical system and enables the onboard diagnostics to reset and gather essential real-time data. Next, use the Honda Diagnostic System, HDS, to check the MAF sensor parameters in the data list. The readings for the airflow should indicate around 202 grams per second, or GPS, or a voltage of 4.89 volts or more. If these parameters are met, you'll proceed to the next troubleshooting step. If they do not meet this threshold, it indicates an intermittent failure, suggesting that the system currently appears functional. This situation necessitates checking for poor electrical connections or loose terminals at both the MAF sensor and IAT sensor connections, along with the PCM. After confirming the data from the MAF sensor, the second step in troubleshooting DTC P0103 involves turning the ignition switch off to the lock position, which is represented as 0. This action ensures that circuit changes can be safely made without risking electrical shorts. Following this, you will use the HDS to jump the SCS, service check switch line. Jumping this line allows further diagnostics to be performed without interference from other systems. Subsequently, disconnect the MAF sensor/IAT sensor 5P connector to isolate it from the circuit. This step is vital for checking the integrity of the wiring and connections further down the line, without the MAF sensor influencing the voltage readings during the continuity tests that follow. The third step in diagnosing DTC P0103 involves disconnecting the powertrain control module PCM connector A, which typically has 49 pins, known as the 49P connector. This step is necessary to access the wiring running between the PCM and the MAF sensor, allowing for a thorough continuity check. Following the disconnection, the next task is to check for continuity between terminal A9 on the PCM connector and terminal number 2 on the MAF sensor IAT sensor 5P connector. Ensuring continuity is crucial because it verifies the electrical path between these components. If continuity exists, it confirms that the wiring between the PCM and the MAF IAT sensor is intact and functioning. However, if no continuity is detected, it indicates an open circuit or break in the wire, necessitating repair to restore the connection and functionality. In the fourth step of the troubleshooting process for DTC P0103, you should begin by reconnecting the PCM connector A, ensuring a secure connection. With the PCM now back in place, the subsequent action is to use jumper wires to connect terminals number 2 and number 3 of the MAF sensor/IAT sensor 5P connector. The purpose of this jumper connection is to bypass the sensor temporarily, allowing you to mimic a specific input situation to test circuit functionality without the sensor actively influencing readings. The importance of this step lies in confirming whether the circuit from the MAF IAT sensor can properly send and receive voltage signals, which is a crucial requirement for effective engine management. Once repairs or replacements are made in response to DTC P0103, the final verification step is critical to ensure that the issues have been successfully resolved. Start by clearing any diagnostic trouble codes with your diagnostic tool, which resets the vehicle's check engine status. Following that, conduct a test drive under various operational conditions to allow the ECM to learn and adapt to the changes made. It is essential to closely monitor the vehicle's performance during this drive to assess for any signs of persistent issues or returning error codes. If the vehicle operates smoothly, without the check engine light illuminating, and without any performance drops, this confirms successful repairs. Should any issues persist, re-evaluating the previous steps may be necessary to identify additional problems. Preventive maintenance is critical in avoiding future occurrences of DTC P0103 and maintaining overall engine health. Regular inspections of the MAF sensor should be part of routine vehicle maintenance practices, ensuring that dirt, debris, or potential damages are identified early. Additionally, check and secure electrical connections at both the MAF and IAT sensors, as corrosion or loose terminals can lead to operational issues. Maintaining the entire intake system, especially the air filter and air ducts, ensures maximum airflow efficiency, which is essential for proper MAF function. By staying vigilant with these steps, you will significantly decrease the chances of recurrent issues and extend the life of your vehicle's engine management system. In summary, understanding the role of the MAF sensor in your Honda Odyssey is crucial for effective vehicle performance management. When faced with DTC P0103, systematic troubleshooting allows for precise identification of the fault, whether it is due to the sensor itself or related wiring issues. By diligently following the troubleshooting steps outlined, you can accurately diagnose and resolve the problem. Additionally, regular maintenance practices play a significant role in preventing similar issues from occurring in the future. Keeping the MAF sensor and related components in optimal condition directly correlates with engine efficiency and mitigates unwanted performance disruptions. Adopting these strategies will keep your vehicle running smoothly and efficiently. Please like and subscribe to the channel. See you next time.